Welcome to the LPG as a fuel panel. This is day 2. We are discussing about fuel options for the future. The environmental performance of LPG as a fuel is close to LNG with some advantages we'd like to discuss, both of them being fossil fuels. LPG is maybe the best dual fuel option for the significant existing fleet of LPG carriers. And furthermore, bunkering is one of the key benefits of LPG, given the existing infrastructure, terminals, LPG carriers, providing a vast network of outlets, improving the suitability of the LPG as a marine fuel. Here, with GREEN4SEA, we have hosted the first panel of LPG as a fuel back in 2017. We have several milestones from that point onward, and we would like to discuss in this panel market momentum, success stories, key challenges, drivers and barriers, the same more or less agenda we discuss with all the fuel options today, CAPEX, OPEX, fuel price considerations, and overall competitive strengths and weaknesses of this fuel, of LPG, compared to other fuels. So in order to have this discussion, we have assembled a panel of experts. Let me introduce them to you. We have in this panel Nikos Xydas, who is the Technical Director of the World LPG Association, Aabo, who is the Director of New Technologies for Sales and Promotion of Two-Stroke Marine with MAN Energy Solutions, Christophe Coppet, who is Project Manager with Exmar, and last but not least, Peter van de Graaf, who is Account Manager based in Belgium with the Lloyd's Register Marine and Offshore. Gentlemen, I would like to welcome you all to this panel. And as we have the introduction as the first order of business out of the agenda, we would like to commence with a presentation. The second order of business, we would like to have a set of presentations. And I would like to ask Nikos to share his screen and let us have his initial opening to the panel. Nikos?
So a very big welcome, good morning and good afternoon, good evening to everyone, wherever you are. First of all, I would like to start with a big thank you to Apostolos and the GREEN4SEA organization. Always excellent events. So I'm sure this is also one of them. A short introduction. I'm Nikos Xydas, and I'm the technical director of the World LPG Association. The World LPG Association is, of course, the LPG association that covers, has under its scope the entire world. We have more than 300 members around the world, and they come from more than 127 countries. We cover the entire supply chain from producers, manufacturers, shippers, distributors, of course, of LPG, and obviously not only for marine, down to the user. So it is the authoritative voice, as we like to say, of the LPG market in the world. Going now to our subject, the LPG for marine use. As Apostolos mentioned before, we started in 2017 with working together and presenting all the benefits of the fuel for the marine world, and not only for big shipping, but also for smaller commercial boats. Most of them now, they are known. You can see on my screen what are the benefits of the LPG. 99% we say down in SOx, 15% in CO2, 10% less in NOx, 90% particular matters. These are compared to 2020 compliant fuels that we have. Of course, LPG meets the IMO 2020, but the great thing is that it also supports very much the greenhouse gas strategy of IMO 2050, because simply it is not a methane, it is not a greenhouse gas. It does not have the methane sleep issues that we know, so it has no global warming from this point of view. Often we like leaving others to talk about LPG. So what you see up on your screen, it is what Bureau Veritas says about LPG. That was a comparative table that they had made, and as you can see, they talk about only advantages for the LPG in comparison with all the other options and other fuels that they had considered on this table. One of the big advantages of the LPG we like stressing, it is bunkering, it is availability. Well, the LPG, it is a very, very, very old industry, and LPG is around for 100 years, I think. Available now everywhere, all over the world. Everybody can have access to LPG. So in terms of marine, there are more than 1,000 existing storage facilities and terminals. We have more than 700 smaller vessels which can be used for ship-to-ship bunkering. And of course, every other terminal, every other storage facility that exists can be converted to be a bunkering point. So from this point of view, it is, I believe, the most advanced and most widespread fuel. There are already 4 LPG-powered vessels today sailing, and these are from B&W LPG. There are more than 71, we understand, vessels which are either in the pipeline or already built. Already built are the 4, and more of them are coming. What MAN used to say when they launched this engine was that and still say, in fact, is that in 2021, maybe 60% of the new builds of LPG carriers will be LPG powered. By 2027, they expect that 100% of these vessels will be LPG powered, and by 2028, maybe 30% of even the container ships, new ones, of course, will be LPG powered. However, this is not the only thing, the fossil LPG, the LPG that we know, and a big advantage really of somebody who uses LPG is that can pass tomorrow to the bio-LPG, to the renewable LPG, as we say, very easily. There is a summer product already in the market which is used for transport or heating today, and there will be much more coming in the future. The association is working very much on this aspect. Really a very good light in the future, also by passing from the LPG, we know the fossil LPG, to the bio-LPG, to the renewable LPG, which comes from a mix of feedstocks, so waste, residues, vegetable oils, and much more. With this, with bio-LPG, we say that we will be able to reduce even further by maybe 80% the carbon emissions. And even more than that, when we start considering, and we are already considering, mixes of other fuels, like, for example, renewable DME, which may be coming in the future. So, in summary, LPG, we see only advantages. It is a proven fuel, as Apostolos was saying before. There is a tremendous experience, everywhere on the use of LPG, its safety, its operation. It's a very good pathway to a net zero carbon future, as we say, either with carbon capture in the future, or also with passing to ammonia. We know that LPG installations, LPG facilities are with very little change compatible with ammonia. And the same, of course, with the ships. We'll be running LPG can pass to ammonia tomorrow with very small modifications. And with the renewable LPG, it's really the great cherry on the cake. And of course, WLPGA is there to support all its members as we usually do. So that's all from me, and I would like to thank you, to thank everyone for listening. So back to you, Apostolos, and I'm available to answer any questions.
Thank you very much, Nikos. Let's hear from Peter. Peter, if you could share your screen and let us have your presentation, please.
Okay, thanks again to all of you for giving me the opportunity to talk about the applicable ruling for the use of LPG as a fuel. At this moment, the only vessels who are using LPG as a fuel are mainly the LPG carriers, and therefore the IGC Code is applicable, as well as the rules for LPG carriers from LR, where Chapter 16 is linked to the requirements for LPG as a fuel. The approach of LR to use alternative fuels are mainly based on a risk-based approach, which is mandatory for LPG as a fuel. So the risk-based approach is starting with the safety declaration of the design of the equipment and the vessel, followed by a hazard and a HAZOP, and after preventive and mitigative measures, they will go to the final design and the plan approval office. So something to say about this, the risk-based design. The team who is doing the hazard for the risk-based design is a different team than doing the final design assessment. One thing to be said is that it's very beneficial for the hazard to have already an observer from the plan approval office available, who is not actively taking part of the hazard, but who is listening and who can, at a later stage in the plan approval stage of the documents, better situate the decisions that have been made during the risk-based design. The risk-based design is supported by a ShipRight document from LR, which stipulates the procedures to be followed. The risk acceptance criteria is based on the likelihood and the consequences of the events that can happen in any part of the system of LPG as a fuel. In my opinion, the positive and honest approach of the hazard to achieve a good risk-based design is crucial for the development of alternative fuels. All the SMEs and partners around the table should be convinced that they have used all their knowledge to come to a safe design. Failing of a hazard could result in accidents. This could jeopardize new technologies with alternative fuels to proceed in further materialization. So it's crucial for that the hazard is done in a very proper way to be able to provide a safe technology. The IGC Code is also referring to the alternative fuels technology, and there are some special requirements as indicated on this slide, which are looked at and which are considered during the hazard. As for the documentation required, on this slide you can see a list of documents that need to be provided to the hazard team and later also to the plan approval office, apart from the traditional drawings of hull and machinery, to have LPG used as a fuel on the vessels. On this slide, you see that the special requirements for exhaust temperature gas control gas detector systems and the depressurization of the liquid containing fuel lines, how they have to be dealt with, and which requirements are available for these this part of the system. There are also special requirements for the annular space of the double wall concept of the fuel lines in the engine room, to where you lead the outlet of the annular space ventilation, etc. So these things are all considered during the hazard and also reviewed during the final plan approval. Some items that will also be considered during the risk-based approaches, like possible spillages, the risk with fuel storage, the leak detection. But what needs to be said is that, especially on LPG carriers using LPG as a fuel, the system is, let's say, starting from the deck tank. So it's a traditional gas carrier where the deck tanks are already available for a long time. So that experience is there. So what is new is the fuel supply system and the treatment of the fuel towards the engine. When the vessels are complying with the requirements of the IGC code and the requirements of the gas code, there is a class notation LFPF, GC standing for gas coming from cargo, and LP for liquid petroleum. What you can also have as a class notation is that LP is changed for PG, which stands for petroleum gas. Now, as our track record from experience, I am a little bit fortunate with having a company like Exmar in my area. So we were already involved in the feasibility of LPG as a fuel in 2012, with a hazard done in our UK office in 2012 September. And unfortunately, because it's not only the designers and the owners who had to be convinced about LPG as a fuel, it was only materialized lately with initially, I think, with the order of the vessels in Subic Bay, and later with the vessels built in Chang'an, the Bihui vessel, and other vessels which are in the pipeline. So I think so. LPG has a quite solid case, and I think later Christophe will elaborate more on that. So thank you for your time, and I'm happy to have further discussions and answering questions later. Thank you.
Thank you very much, Peter. Now let's move on to Kjeld. Kjeld, can you please share your screen and let us have your presentation?
First of all, thank you very much for the organizers of GREEN4SEA for inviting us. My name is Kjeld Aabo. I've been 38 years in MAN Energy Solutions and have worked a lot with fuels, loops, emissions, and so on in different departments. Today, we talk about LPG as fuel in our engines, and this is my presentation. See, just to start, I would say that normally we are sitting in Copenhagen, all of us, when it comes to the two-stroke engine, it's here we, for MAN Energy Solutions, design and develop our two-stroke engines. We have a production of spare parts also. We have prime serve academies to educate marine engineers to operate our engines, also with the new fuels, of course, dedicated special courses. We have our research center, and we have a diesel house. Diesel house is a kind of museum. If you come to Copenhagen, it's very interesting to see this huge double-acting two-stroke engine in this museum. Research center, yeah, I was in charge of the research center about 12 years ago, and I had 30 engineers in the group. Today we have 65 plus in the research center, and as you see on the right side is a new test engine coming in to supply, you can say, the huge demand we have of testing here the last decade. So now we have two full-scale engines operating in our research center. So this is our engine program. I don't want to go too much in detail. It's just so you get a view of what we are talking about. It's not small sewing machines. It's engines up to 2,400 tons for 12 cylinders. On the biggest one, giving about 83 megawatt. We have also the smaller two-stroke engines here going down to about 3 megawatt. We have a lot of engines here in the engine development, and you see a lot of overlap of the different engines, and that's because we need to satisfy all these, you can say, the requests from the market, from the naval architects, from the ship owners, and so forth, so they will get an optimum engine for their application, if it's container vessels or it's tankers or what it is. Today, our dual fuel portfolio consists of engines that can burn LNG, ethane, methanol, LPG, and in the near future also ammonia. We have, for the LNG, we have actually two working principles. We have the diesel principle and we have the Otto cycle here. But when it comes to all the other types of dual fuels like ethane, methanol, LPG, and ammonia, it's based on the diesel principle and not the Otto process. This Otto process was something we have launched to the market, which is, you can say, introduced basically for the LNG carriers, where when you use the diesel principle, you have to use a high and very costly two-stroke compressor, boosting the boil-off gas from the storage tanks up to 300 bar, and that is given a very high CAPEX, and therefore many customers, they choose the Otto cycle. So we have also that. But let's go back to the diesel principle. It's actually what we see here, like a normal engine. The dual fuel engine is a diesel engine where we have added on the injection system for this type of fuel oil, a dual fuel. So if you look here, you see this normal fuel oil burning engine, and now you see what's popping up here is actually the add-ons on the engine itself. We can also see it here, closer view, in cross section. It's all around the top of each cylinder where you have a new cover. You have, because you have these dual fuel valves also introduced, you have a distribution block, and you have a double wall piping and so on. So we have, when we look at the valves, we have for you can say the fuel valve for the LPG, we have here a fuel booster injection valve. So it's both a booster pump, you can say, and also a valve in itself to get the pressure into the cylinder. We have here the normal pilot oil valve that, of course, also can supply 100% fuel oil if that is what you want to operate on. This engine, the diesel engine and diesel principle, is not very sensitive to the fuel oil itself and the LPG. Here in this case, we should have minimum 75% of propane and butane and maximum 25% of ethane, but that doesn't seem to be any problem in the market as such. So if we look at it overall about using LPG for propulsion, yeah, new building projects as well as retrofit references, we have actually ordered now on and are retrofitting 15 MEC engine to LGIP engine, which is the dual fuel propane engine, and that is for PV gas. We have already, Nikos have informed about the differences here on the emission side. I don't want to go into this. And what is important, of course, is also the attractive fuel price, traditionally lower or the same level as heavy fuel oil, which also is quite an important part. And what we see is that it is actually going to be an industry standard, because today, in this time, almost 100% of very large car carriers carrying LPG is actually ordering such engines. If we look a little bit of how it's you can say the specifics for LPG, yeah, -42 is not that much compared to LNG, for instance. We have an injection pressure in the fuel gas supply system on 50 bar, but an injection to the combustion chamber about 600 to 700 bar. Actually quite close to what we expect will be the situation for the ammonia engine. But that we are going to test, and based on the testing, we will know more about where we land on that part. We are in full process. Retrofit, I talked about retrofit, and the MEC engine, the electronic, fully controlled fuel oil burning engine here, can actually be retrofitted to LNG, LED, methanol, LPG, and in the future also for ammonia. If you have already a TI engine for methane, it can of course also be retrofitted to one of the others. Again, think about this. It's all add-on components to the existing engines, and a very small part of this engine is the dual fuel part actually. When it comes to NOx, we still have to be compliant with Tier 3 and Tier 2, of course. And in Tier 3 case, we use SCR or EGR with the diesel principle. We will still have a high peak temperature in combustion chamber, and thereby also a high level of NOx. So that is taken care of in this way. We have also, and that was Peter mentioning about hazard investigations, we have been through a lot of hazard investigations, both on all the different fuels, and of course also in LPG. So safety is in spot, and also the reliability and availability of the system. This is my last slide. I just want to show you that we have sold totally 79 of these LPG engines, and it's just coming very, very strong. So thank you very much.
Thank you very much, Kjeld. Let's hear from Christophe in order to conclude with this round of presentations.
Good day. My name is Christophe Coppé. I work for EXMAR. It's the technical desk as a project manager for new building vessels. And I'm going to try to explain very quickly how EXMAR implemented everything which has been discussed now already about LPG as fuel on board of our gas carriers, some of our gas carriers. So EXMAR, besides other activities, we are a ship owner. We have about 35 vessels, some fully pressurized vessels, but the major part are mid-size LPG and ammonia carriers. And apart from the mid-size vessels, we have two VLGCs under construction and in Shanghai at Jiangnan shipyard. And these two VLGCs, that was the world's first order for a vessel, for a gas carrier with LPG as a fuel. Two large vessels will be delivered in Q3 of this year, and they will be sailing for Equinor. LPG has been used already quite some decades in the automotive industry, and we bring it now to the two ships because it has several benefits which has been discussed already, definitely when it comes to emissions. And as mentioned by Nikos as well, LPG is available among the major shipping routes around the world. So I'm going to explain now very quickly how such an LPG fuel supply system on board of a ship works. So what you see here is the outline of a conventional gas carrier with a safe zone, which is basically the engine room, and a hazardous zone, which is the cargo deck and the cargo tank. So in the safe zone, you have your main engine, which is supplied by conventional fuel. And in the hazardous area, you have the cargo tanks, the deck tank sometimes, most of the time, and liquefaction units to keep the cargo at the required pressure. And then we add several components. So we add an LPG bunker manifold to directly bunker the deck tanks. We add a fuel supply system with pumps and a heating, cooling mechanism to bring the LPG up to the required temperature and pressure. Then there is a fuel valve train, which is basically a function of a block, which has basically a double block and bleed function. So that is providing the barrier between the hazardous zone and the safe zone, because from the fuel valve train, we go via double walled piping to the main engine. And it has the same principle as you have with conventional fuel. You send more LPG to the main engine than you actually are consuming. So you also need a return line back to the fuel valve train. And then to end, you need a vent system. This was already mentioned by Peter. When the main engine is not consuming LPG, you need to depressurize the double-walled piping, so there is no LPG in the double-walled piping when the main engine is not consuming LPG. Keep it safe. That fuel supply system consists of a high-pressure pump and a low-pressure pump. The pumps which were selected for that are side channel pumps. They're VFD-driven. Side channel pump is like a little bit a hybrid between a positive displacement pump and a centrifugal pump. And the reason that we selected these pumps is that they can give a high pressure at a relatively low flow, and they can cope with the different LPG characteristics. Just as mentioned by Kjeld, you can have propane, you can have butane, and there can also be a percentage of ethane inside of the LPG. As mentioned, the double-walled piping is purged, is vented when there is no LPG consumption. For that, a nitrogen booster system is installed to purge the LPG out of that double-walled pipe. But we don't purge it to the air. No, we catch it. And for that reason, a catch tank system is developed and will be installed on the ship. And the basic function of that is to catch the LPG mixture together with nitrogen, which is purged from the double-walled piping. The nitrogen is vented and the LPG is used again the next time that the engine is started. I mentioned already we have 2 vessels under construction at Jiangnan. The vessels will be delivered soon, but the main engine has already been tested. It's built by MAN's licensee CMD in Shanghai. Shop test took place end of last year. So we checked everything which we should check. The engine ran smoothly on LPG. There was a smooth transition as well from LPG to compliant fuel and vice versa. And also the emissions were recorded and they were all in line with the expectations. So the engine ran perfectly. There were no issues during the shop test. As mentioned already, LPG is a dangerous product. It's an extremely flammable gas. So there are several safety considerations which should be taken into account. So first, as I mentioned already, the whole fuel supply system is installed in the gas dangerous zone, the gas hazardous zone, the cargo deck. The booster pump of the pump, the LPG fuel supply unit, the length of that 50-bar pipeline is limited as much as possible. And from the fuel valve train in the engine room, the whole piping system is double-walled. So what does that mean? You have an inner pipe where the LPG is flowing in one direction, and the annular space of an outer pipe, there you have a constant airflow, 30 air changes per hour, with a gas detector. So if there is a leakage from the inner pipe to the outer pipe, it is immediately detected and the LPG fuel supply is stopped. The engine keeps running, shifts automatically over to compliant fuel. In the unlikely event that there should be any gas in the engine room, there are also gas detectors installed there to detect flammable gases in the engine room. As I mentioned, when there should be an issue with the LPG fuel supply system or there is an emergency stop, the engine automatically shifts over to compliant fuel. So you don't need human interaction there. It goes all in a very safe and sound way. The system of the main engine has been tested in the shop test, and that all went well. And the whole design of the system was built as per the rules from the Classification Society, from the new LPG as fuel rules from Lloyd. As mentioned by Peter, it was a risk-based assessment. So we did a hazard and a HAZOP with all the involved parties when the design was ready, and we did a safety study of the whole concept to verify if everything what was designed is safe and can be built and operated in a safe way. And there will be a sea trial, a separate sea trial conducted on LPG before the delivery of the vessel. As mentioned already, we started with this concept in 2012, where we obtained an approval in principle together with Lloyd, also together with MAN. But it took till 2018 actually before it really materialized. And we ordered together with Equinor these 2 first LPG fueled vessels. But in the meanwhile, we have 13 gas carriers which can be converted, mid-sized gas carriers which can be converted to LPG as fuel. We have quite some experience with handling LNG dual fuel vessels. We have a lot of track record with LPG vessels and LNG vessels. So we believe that we can operate these vessels in a really safe and sound way. And then to finalize, I summarize the benefits again for LPG as a fuel. So there is no sulfur in the LPG, so there is no SOx emission. There's about 10% less NOx emission. We have 15% less CO2 emission. Particulate matter is reduced with 90%. There is no hydrocarbon slip because we use the diesel principle in the engine. And you actually don't require bunker stops anymore because you can use your cargo as fuel. So that brings me to the end of the presentation. Thank you for your attention.
Thank you very much. Thank you very much, sir. I would like to start our discussion about your, let's say, recent and what you look forward with respect to success stories. We would like to discuss the suitability of the LPG as a fuel compared to other options in the market. And I would like to start with the success stories. Christophe correctly pointed out they are working in Exmar for the past 8-9 years with LPG as a fuel. And it was nice that he highlighted some practical issues. I would like to start my first question back to Christophe. How challenging, because I think Nikos pointed out, how challenging the operation of LPG as a fuel might be for someone who is not operating LNG or LPG or gas carriers, let's say in general. How challenging this may be?
It's on an, so, yeah, if you install it on a non-gas carrier, so on a conventional ship, of course you need to comply with the IGF code. So there are already some challenges which you should tackle in the design. We build it as per the IGC code on a gas carrier. I don't believe if the crew is properly trained to handle gases, I don't see major difference with LPG compared to LNG. LNG is already installed on non-gas carriers, and I don't see a big difference there between the LPG and the LNG.
Okay.
That answers your question.
Okay. I would like to start from Nikos. I would like to hear from you your recent, let's say, what you think as a milestone or a success story as we move forward. IMO 2020 was a milestone for the industry. LPG is fully compliant with 2020. There was no problem with that. What you see as we move forward? What might be, let's say, success stories? Again, I would like to also ask you to compare the issue of the LNG as a fuel, because we hear a lot of, let's say, milestones and success stories over there as we progress. It doesn't happen from one day to the other. What sort of milestones do you expect in the market? Nikos.
Yeah, thank you, Apostolos. Well, first of all, I would like, before going to the answers of your questions, I would like to make one or two remarks. First of all, we should all appreciate that this is here a panel of pioneers. Yeah. We have Lloyd's, who pioneered the designs. We have Exmar, who dared to be the first one to start building LPG-powered vessels, and we have MAN, who has built the engines. So this is the absolutely top tier here of the pioneers as you have as panelists, Apostolos. Now, on the questions you had as milestones, I think a very important milestone. It will be the first non-LPG carrier vessel. You put the question already, Apostolos, and we would like to see ourselves in the association another vessel. Probably, I don't know, maybe we start with container ships, but we have also put some efforts by discussing with passenger ship operators to convert to LPG, because it is very simple. As we said, it doesn't need the infrastructure, with LNG, and we think at least for short routes where you can find everywhere around the coast LPG infrastructure to bunker, it is very simple. It just has not taken up yet, but it's always for the first one to make the big start, okay. And then we see that the others follow.
Okay. Peter,
No.
your take. What would be a milestone that you expect from your end?
I think, okay, just going back to 2012, where we were sitting around the table and talking about how to proceed, and with the ideas of, at that time, the CEO of Exmar saying, look, this could be done. I think there is nothing stopping LPG to become also a fuel on a conventional vessel, as long as you do the appropriate risk assessment, and as long as you do the proper training. And I think some ships maybe are more suitable to use LPG as a fuel than others. But in my opinion, and it's I should also support as in my position any alternative fuels actually that will be used, whether to improve the environment. We should look at it, and the technology of LPG at this moment, I think, is quite mature to be implemented on other kind of vessels. So, yeah.
Okay, Kjeld?
Yes.
So what sort of milestones? I think you mentioned 79 engines, and you said it's extremely promising.
It is very promising, and I think a big milestone is that almost 100% of these very large propane carriers are actually with our engines, our propane engine. So I think this is a very big milestone. There's one thing, we talked about comparing with LNG and so on. If you look at the fuel gas supply system, it's somewhat more simple for the LPG. LPG is supplied to the engine as liquid and not as gaseous gas. And that means that it's the pumping, you can say the cooling, heating, and so on. All that is, as also shown by Christophe, and also showed the diagram, PI diagram, it is very simple and also much cheaper, you can say, than the fuel gas supply system for the LNG. So that, I think, is also something which is important, and Peter, also you or Nikos mentioning also that you don't need the same logistic and distribution network to get actually the LPG, because it is available so many places. So I would say, coming back also to Nikos with the fourth non-LPG carrier, we are still waiting for that, because I believe it will come.
Yeah, at some point. At some point, yeah, it will come. Christophe, your thoughts?
Yeah, I share the same thoughts as the other gentleman. I would like to add that indeed, like Kjeld is saying, and it was also mentioned, it's available along the world, LPG, and we have already the bunker vessels available. You have fully pressurized vessels which can perfectly serve as a bunker vessel, and you just need to do an STS operation with a fully pressurized vessel with a gas carrier, with a mid-size or a very large gas carrier, or another vessel that consumes LPG as fuel, and you're there. So it is actually simpler than operating a vessel on LNG if you operate it with LPG. So I also expect that's soon one conventional or non-gas carrier will be ordered with LPG as fuel. I see that really possible.
May I ask now? I'd like to ask some figures about CAPEX, OPEX, and fuel price. Nikos, can you give us an indication of the differences between fuel prices of LPG versus the conventional diesel we're using and the LNG, briefly?
We heard before that today the price of LPG it's very comparable with the other fuels that we used to use as for marine powering. It is more important, I think, to have an idea of course, of what is how LPG compares with other, that if we can call them future fuels. And particularly with LNG. There was a long time where the pricing of LNG, LPG was very similar, but these prices they go up and down, and they can be quite volatile. Maybe LNG is a little bit cheaper at the moment, but this will not mean that it would be also the case in the future. I know that BW, who is operating now these vessels, and they have a few months of operating experience, they say that with the current prices of LPG, they have a payback of 6 to 7 years, with whatever other alternative they could have taken as an option. So that's how I see it in terms of fuel comparison.
Christophe, you would like to comment?
Yeah, I just want to add that it is true what Nikos says, and the reason for that is that you save on fuel cost because you consume less fuel if you're running the ship on LPG, because the energy content of LPG is higher compared to MGO or HFO, and for that reason you save fuel cost.
Okay, how about Christophe? How about the OPEX?
Well, the OPEX is, if you look to the equipment which is there, will not significantly be higher compared to any other fuel, because what you need is a set of pumps, a heat exchanger, and some piping. But piping, you don't have OPEX on piping, so there will be no significant increase in OPEX there.
Okay, and how about the CAPEX?
If you look at CAPEX, and then I look at the complete vessel, maybe Kjeld can give you some insight on the engine itself. If you look to the complete vessel, then it's about 10% more than a conventional non-LPG fueled gasket. That's a little bit.
That's okay. I just need some indication for our audience to understand how far or how close LPG stands against other options in the market. Now, I would like to ask, given this discussion we have in the industry about carbon tax and where we are headed.
Sorry?
Yes.
I would just say that I think, Christophe, that it was turned around CAPEX, OPEX, wasn't it? Or was it just me? I think CAPEX, you answered CAPEX for the OPEX and OPEX for the CAPEX. Is that correct? Or is that my misunderstanding?
CAPEX is about, for the complete ship, about 10% more than a conventional gas carrier, which does not operate on LPG. The OPEX is more or less the same, because you're not having more equipment running if you run on LPG compared to when you run on HFO.
No, that sounds right. Sorry.
I would like to ask you, given the ongoing discussion about the future tax on carbon imposed in the EU, and most probably what we know now will be changed in the near future, do you see any sort of green incentives or any sort of other incentives in the market that will push towards adoption of LPG as a fuel? Nikos?
We are in discussions on this matter. I'm not sure if I can tell something specific. We know that, of course, the focus it is in this discussion on other segments like transport, like heating. But the marine is following, so I am participating in some such discussions, but maybe they're not yet mature enough to be able to give some indications, but I'm sure it will be coming.
Do you think that LPG may be part of the end solution? Because we hear a lot of discussion and and ongoing issues about these fuels, maybe something like a bridge fuels, and it not maybe part of a carbon or zero carbon solution that we expect to see in 2050. Maybe we see the European Union looking towards, with the Green Deal, looking towards 2030, maybe no emissions imports, and maybe 2050 for carbon neutral. So how do you see these developments? How does LPG stands over there?
Yes, Apostolo, this is what I had in mind also, the discussions on the Green Deal and the discussions of whether not only LPG for marine, but LPG in general is an important part of the solution or is not. In our view, obviously, it is an important part of the solution. We like to say that LPG is a transition fuel for forever, if I can exaggerate a bit, but it can take us really a very long way. And we must not forget that, as I mentioned before, that LPG has as a drop-in replacement immediately the bio-LPG or renewable LPG, as they call it maybe in other places in the US. So it really takes someone a very long way into the future, into 2050. But I don't think that the discussions are mature enough so that we can really mention something or with credibility. This is what I want to say at this moment.
I understand what you're saying, because we don't know the exact parameters that this discussion should be conducted. So a number of issues are unknown for the time being.
Yeah.
I would like to ask the other panelists, what do you see as the main barrier, let's say, to put in that sense, from your perspective, that we have to fight towards adopting LPG as a marine fuel? Peter, your thoughts? More or less what you presented, more or less the regulatory issues are more or less in order. What sort of other barriers do you see towards accepting LPG as a fuel in the future?
I think the barriers and that's not only for LPG, that's for all the alternative fuels, is the perception the perception can be a barrier, and the previous topic you mentioned, I think all fuels will play a part in the future fuels, and because we don't know what will be happening, let's say not tomorrow, but all these technologies will be maturing. So LPG is there, it has some emissions, but it will also be maturing. Hydrogen is there. You were talking, people were talking about 2040, 2030, but these technologies need to mature, and we need to give these technologies a chance. And that's what I put forward when I was talking about risk assessment. It's the honest approach of the members of HAZIT Teams meetings to be sure that we put forward a safe technology. And safe technology will be more mature, but for some fuels, or for the fuels who are just coming to light at this moment, it will take some more time. LPG is already there. So the only thing what has to happen is it will become more mature and other solutions will be found. So that's my opinion.
Yeah. Okay. Kjeld, what do you think are the key barriers?
As technology providers, we listen to the market to find out what is needed out there. Our goal, you can say a little bit, a dream was to have one engine that could actually operate on all the different fuels, because then you could go in the transient period, and when you can say there are maybe a CO2 tax or whatever to get equal ground with pricing of fuel and so on, that could go. But we are definitely working on doing things like that. We have to test our ammonia engine before we know more about what can be done for one or the other situations. But if we look at the characteristics for LPG and ammonia, they are not that far. It's the same impression, you can say pressure you boost into the combustion chamber, not as exactly the same fuel oil supply system pressure, but it's relatively close. So there are some synergies there, but we will know more when we have made the testing. And the idea on the long scale is that we will try to you can say, put technologies, make platforms that where you can say liquid gases have almost the same design or very little have to be changed. But this is in the future, but it's definitely a goal we have.
Okay. And Christophe?
Must be for barriers, but we are building such a such a vessel, so we know it works.
Yeah.
Basically, I don't see any barriers personally, but I share the opinion from Peter that indeed it is perception, and it's perception which is out there, which should be tackled, because basically the system is there, the system works, the system, as already mentioned, is easier. Basically, if you compare it, for example, with LNG as fuel, it's an easier system. So there are actually no barriers, but still, it's only ordered for gas carriers. So then the reason I think is indeed perception, and it should be a little bit. The word should be spread that there is also, apart from LNG, there is also an option, LPG as fuel, which has more benefits than the LNG. So maybe this kind of sessions will contribute to that.
Okay, and now I have to wrap up the panel. I would like to ask my last question. I would like to hear your thoughts. Are there any lessons to be learned from the LNG, adoption as a marine fuel, and apply these to LPG as a marine fuel? Or maybe if you would like to state something like a wish list, what would you like to see to the market that would accelerate, let's say, the adoption of LPG as a fuel? Because I fully understand and fully agree with what Christophe said, that, yeah, there's a fuel over here, many advantages, and it's as good, if not better, than other options. So, Nikos, your thoughts?
Well, I would start maybe, Apostolos, to add to the previous thing about the barriers, which I think that it's related also to your question. It is the perception that LPG is fossil fuel, and whatever has to do with fossil fuels, it's not for tomorrow. This thing needs to be sorted. Defossilization is not something which happens from one day to the next, and so this is a very important perception issue. Now, on the barriers, also, I want to say that the engines, maybe it is something that LPG is still not really to the point for other smaller vessels. From Korea, for example, I have been getting a lot of inquiries. They are telling me that in shipyards there, they want to convert to LPG, and they don't have smaller engines, and they are looking for them. So this is maybe also something for MAN, to look at. Sorry, your question, Apostolos, so maybe I move to something else. Could you read again?
I was just saying, what may be the lessons to be learned from the LNG?
Yes, exactly, the lessons. So the lessons that for me from the LNG uptake was that wherever you really provide incentives and funds, and we know some huge incentives and funding has gone into the LNG business and has not gone into the LPG, this makes a huge change. So this is a lesson for me. If you really put the right incentives into it, then things grow. If they don't have the right incentives, things they grow, but they grow in a much smaller pace, and which is the case with LPG, where we try really very, very hard, despite the fact that there have not been all these incentives and funding coming into as it was the case of LNG.
Yeah, I also have to add to what Peter said, because it's the perception is an issue, and what we've learned from the LNG is that it takes time. We've learned the hard way. It takes time for the market and for the people. I fully agree with the incentives, but it also takes time, because it's what Peter said earlier on, and it's something that we have to also bear in mind. Peter, what else would you like to add to the discussion? Any lessons to be learned from what we've seen from the adoption of the LNG as a fuel, or maybe a wish list?
I think I would like to, let's say, I will put a political answer forward. So I think we learn every day. And I think the lesson that we should learn is that, of course, we are now talking about LPG and people are pushing LNG and other fuels are maybe a little bit pushed, but we should go for the safe options. And this can be different for different owners, different areas where vessels are operating. But the main idea of everything is we should go for decarbonization. That's something we should go for. And we have LNG, we have synthetic LNG coming, we have LPG, we have synthetic LPG coming. So there will be a lot of solutions. And the main aim of alternative fuels is carbon footprint. And I think that's the main thing we should keep in mind. And that's my wish list, that everybody is aware of. It doesn't matter which technology you're going to use. It has to be a safe technology, and it has to become more and more environmental friendly. And that's actually my wish. I'm a little bit gray, and I have children and grandchildren. So that's the important message, I think, from my side. Yeah.
That's okay. Kjeld?
Yes.
Your thoughts?
Yeah, first of all, I would like to comment a little bit on Nikos. I fully agree. It's limited a number of engine sizes that we have ready for LPG, or can say the design ready. This is something that the market have to show us what is interesting. Will there be a population that will also, you can say, cover the development and so forth. And this, of course, when we see 79 engines ordered already within the last 2 years for LPG carriers, then of course, this also is something we listen to. We have actually already introduced a 35-bore engine on LPG, and that's the latest one. That's one of the smallest two-stroke engines we have. So it's coming, but it's demand from the market that they have to tell us. Market have to tell us what direction to go for. I also agree with Peter when it comes to this variety of different. It's like a palette of different fuels that will be used. I don't believe that from one day to the other it will be ammonia or things like it. It will come slowly. The technology have to be there, and as technology provider, we try to, you can say, support in the way with these new technologies. I don't see any, you can say, if you compare with LNG as you asked for, I don't see any so much lesson learned other than they have in our engine program. Almost all the engine bore sizes are available for GI because there's a huge application outside the carrier market.
Yeah. And Christoph, you have the last say, as I said at the beginning.
Well, I think everything has already been said a little bit. So I agree totally with what has been said. I have not a lot to add anymore to that. But if you want to talk about a wish list, we are discussing now a two-stroke engine with a fuel supply system and to propel the vessel. In the next step for LPG as fuel should then be that there are also auxiliary engines, 4-stroke engines available which can run on LPG, so that also your auxiliary power can come from that fuel. That would be then the next step on my wish list if we are talking about LPG as fuel. There are also several other options there to do it in an environmental friendly way.
Okay, I would like to thank you all. Thank you for this informative discussion. I'm sure that viewers have their thoughts, and I think we, let's say, educated them towards accepting and adopting LPG as a marine fuel. So I would like to thank you for taking the time, thank our viewers, and trust we look and forward to seeing you, let's say, in one of our future events. Thank you very much.
Thank you very much.
Thank you very much. Bye-bye.
Bye all.
Bye.
Thank you, Nicolas.